Good evening. Good evening. Good evening and welcome to today's session. Today is the 11th week of the problem solving session for this course. We'll be dealing with problems that will be there from lecture 50 to 54, the 11th week's lecture, based on rainwater harvesting and artificial groundwater recharge. Will also be also the due date for the assignment 11th is tomorrow, the 9th of October. So as usual, I'll be posting some questions in the PowerPoint slides to which you'd have to provide the answers in the chat box. And after which I'll be discussing about the explanation or solution of that problem. Along with that, I'll also be revising week 2 and week 3's some questions today. So that will be about today's introduction. Let's move on to the questions. First question is, the rainwater harvesting is an ideal solution to arrest which of the following? Declining trend of water level, increased trend of water level, it has no effect on water table, or none of them. You can post in your answers in the chat box. Okay. So with respect to this question, we require rainwater harvesting is something that is to be considered due to various factors that includes primarily to meet our increasing water needs or water demands. Secondly, water availability is a crisis these days with the availability of water from sources like surface water sources like lakes and rivers, as well as from groundwater is varying. There are cases or instances of depletion of water level, uh, drying off of rivers, etc., which is making it necessary that we go for methods that will provide us water other than these resources. Then there is also our responsibility to protect nature or to take measures to conserve whatever water we get. Then again, there's the advantage of being able to collect and store this water and use it from a very nearby location. Like if you're doing rainwater, rooftop rainwater harvesting, this is a the collection as well as the storage is just near to or on top of a house, which is making the accessibility very good, and also the quality of water obtained will be better. The question here is, it is an ideal solution to arrest the declining trend of water level. Obviously, the water levels increase maybe regionally, yes, but as a result of climate change, the water resources availability is very critical. So the correct answer for this question would be option A. It is helping us in uh, finding a solution towards a declining trend of water. Moving on, second question, which out of the following is not a technique to harvest rainwater? Which out of the following is not a technique to harvest rainwater? Is surface runoff harvesting a method of rainwater harvesting? Rooftop harvesting, is it a method? Rain saucer, is it a method? Filling under the tank with surface water, is it a method of rainwater harvesting? Is the question. Okay. So there are various various techniques to harvest rainwater. One of the most common technique is rooftop rainwater harvesting, that is collecting rainwater in the terraces of a roof, or collecting rainwater that flows down the slopy terraces into uh, pipe systems, which is collected and that can be used. So there are not only that, there are several other techniques also to harvest rainwater. One is surface runoff harvesting. Surface runoff harvesting is nothing but water before it is collected into reservoirs instead of losing it to runoff. So, say it rains and we have a sloping provision, we have a sloping path, then we can collect that rainwater into a system that comprises of a method to collect this water from the slope and use it. So this technique will be surface runoff harvesting. Then, like we discussed, rooftop rainwater harvesting. It is nothing but whatever water that is falling on the roofs are collected and directed towards storage tanks, which is later on uh, filtered and disinfected and then reused. This is also something that can help in groundwater recharge or aquifer recharge if it is being collected in such a way that replenishing of the groundwater also happens. Suppose it is not getting collected in a tank, but instead it is being sent into a well, then this will also help in replenishing groundwater. Same is the case of surface runoff harvesting. So collection points and storage points, if it is if the storage and collection is occurring in such a way that it is in at par with the ground and there's a seepage possible to the ground, then this is also going to serve as a method to replenish the groundwater. Then dams are also a technique to collect the rainwater. We know that water flows into these dams, or water that is collected, water that falls on these dams are also collected. So this water is also one method of rainwater harvesting. Then there are underground tanks. Underground tanks are constructed by digging into this ground space which is below the surface of the ground. The top is covered, and then water is allowed to go into these underground tanks, and as a result of sedimentation, and then there can be filtration processes also applied. This water can be used accordingly. Then there is something called a rain saucer. It is something that collects the water that is directly falling as rain into in a format like this. You can see that there is this inverted umbrella type of structures into which water will fall, and they'll collect this water into a small tank or a storage device. So it's a very simple method, but it is a very innovative and useful method that can be used for collecting rainwater. Then there are water collection reservoirs that is kept at places like similar to surface runoff harvesting. There are reservoirs or storage facilities that can be made at different points on the roads and pavements to collect rainwater. Barrages is another thing. Slopes is also one way where you can collect the water at the bottom of the slopes. So there are various methods through which you can collect rainwater. The question here, again, the trenches is another method. You can see there are water trenches, the particular depth and width trenches are constructed, and this can be used to collect water. Rain barrels also, something like rain saucers only, except this can be collected in big barrels. So these are different techniques of rainwater harvesting. Out of this, filling underground tanks with surface water will be the wrong answer. Rain saucer, rooftop harvesting, surface runoff harvesting, all of them are options for collecting rainwater. This is involving filling tanks with surface water, which is a method of artificial recharge, but not rainwater harvesting. So the correct answer for this question would be option D. Moving on to the next question. Rainwater through rainwater harvesting is used for which of the following purposes? Can it be used for agricultural purposes, for flushing, washing vegetables, or can it be used for all of these? You can drop in your answers in the chat box. Moving on. So these are some of the uses of rainwater harvesting. Very obvious question. So we can say that water through rainwater harvesting or not, it can be used for all of these. It can be used for agriculture, domestic purposes, yeah, for drinking, cooking, uh, gardens, in toilets, lawns. There are various methods of, I mean, there are various purposes for which rainwater that is harvested through rainwater harvesting systems can be used because it is relatively a cleaner source of water because it is obtained directly from the rain. And provided we provide some kind of methods of mm, primary treatment like sedimentation and filtration, the quality is going to be really good. So it can be used for anything, ranging from domestic to washing vehicles, fire protection, etc., depending on the quantity. So the correct answer for this question would be option D. Next question, what is the importance of rainwater harvesting out of these? Which one is the importance of rainwater harvesting? Is it important because the cost of collection is less? Is it important because it helps in improving the quality and quantity of groundwater? Or is it important because it can be used for domestic purposes like drinking as well as irrigation? All of the answers are and options are uh, indicating the importance of rainwater harvesting. Okay. So all of these, the cost of collection is less. Like we had gone through some rainwater harvesting techniques. The methods used for collecting this water was not very sophisticated, simple techniques. So that is one reason. Again, quality, quantity of groundwater, all of these water that is collected can be used to replenish groundwater as well. So can be used for a variety of purposes, ranging from domestic to commercial to irrigation, etc. So rainwater harvesting is thus important for a lot of these. Now, which out of this is not a component of the rooftop rainwater harvesting system? We are talking about a rooftop rainwater harvesting system alone, and there are various components to it. So, which out of these four options is not a component of the rooftop rainwater harvesting system? So a typical rooftop rainwater harvesting system uh, consists of three basic components. There are a lot of components associated with rooftop harvesting, but primarily, it has to have three basic components. One, which is the catchment or the part which is going to collect the water. Second, the uh, sys- portion of the system that will help in transporting water. And third is the system that is going to help in storing the water. So these three components are very important for. Without these three components, there's no rooftop rainwater harvesting. So mainly there are three components. One is the catchment or the roof surface to collect the rainwater. The delivery system that comprises of a series of pipes that is going to help in collecting or transporting the water from the roof to the storage device, and then a storage reservoir or a tank to store the water until it can be used. So something like this. So these are the basic three components. Apart from that, there are a lot of sub-components that are used in rooftop rainwater harvesting, which can be good evening, Hanumanta, which can be which can be added to this. But basically, these three things are necessary. So in this question, we have the sedimentation is not a component of the rooftop rainwater harvesting system, although catchment, delivery system, and transportation components are three major components of a rooftop rainwater harvesting system. So moving on to the sixth question. An 8-inch diameter of PVC pipe filter should be used for rooftops having what area? If the area is more than 1,500 square feet. If the roof area is more than 1,500 square feet, less than 1,500, equal to 1,200 square feet. For what kind of area is this requirement of 8-inch diameter of PVC pipe filter needed? Okay, so let's see first of all, what is a PVC pipe filter, and then we'll go into what are the uh, requirements or guidelines to a PVC pipe filter. So, like how we had discussed earlier, there are various components of the rooftop rainwater harvesting, out of which the catchment, transportation, and storage is the most important. Now, apart from that, there is also something called a first flush. Then there is also, again, here transportation and delivery system are different. Okay, delivery system is after a storage, how the water is used, and then there's a filtration system. So apart from catchment, transportation and storage, there's another component called the first flush, then the delivery system and the filtration system. Now, catchment area, like we had discussed earlier, it is the rooftop. We are talking about rooftop rainwater harvesting. So it is the top of the roof which is going to collect the water. Then it can be the terrace, courtyard, paved, unpaved, open ground, or whatever on top of the roof. Then there's a transportation system. You can see this roof, water this is the collection area. Water from this roof will come and flow into the series of pipes. And from these pipes, it is going to be transported to the storage facility. So this is basically what the transportation component means. Again, a simple facility is this. If you see uh, a more designed pipeline network, you can see that at the edges of all the roofs, there are pipes that will collect water from the sloping roofs and direct it from below the ground to a storage device that is placed underground. This is a system that is implemented in a lot of houses. So This is another depiction of the transportation system. Then we have the first flush. First flush is nothing but when the first when it rains initially in the beginning, the water that comes as a first rain has to be removed because it might contain contaminants that is being carried along with it from the atmosphere when it rains in the beginning. So the system that is used for removing this first shower is called the first flush. um, there are various kinds of, we're not going to the technical details of how a first flush is provided. Although this is what it is something that you require to know. Storage system, like you see here, you can see underground tanks there will be tanks that you can place on the ground, like this you see here. Then we are also seeing the tanks of this form. So anything that is going to store this collected water will come under the storage system. Then there is a delivery system. Delivery system is again two components. One is that delivers water from the collection point to the storage, and another is water that is being transported for the purposes of usage. Now, after the store, if you provide a tap like this, then it is going to be part of the delivery system. So that comes under the delivery system of a rooftop rainwater harvesting. Then there is filtration system. Now this water that is coming, it might have physical impurities. Like if it is being collected from the roof, say the roof is not very clean, then it is going to collect the dust particles from the roof as well. So there are going to be some color turbidity, microorganisms, and so on. So all of these need to be filtered out. And for this filtration, some kinds of filters that are used are sand gravel filter, charcoal filter, and PVC pipe filter. So PVC pipe filter is this filter that we are talking about in this question. So let's see what sand gravel filter is first. Nothing but it is like we've studied about rapid sand filters and slow sand filters. So something of that sort, where water is passed through layers of sand, aggregates, and pebbles. So this is going to help in filtering out the water. Similarly, there is charcoal filter, uh, again constructed by brick masonry, filled with pebbles, gravel, and sand. And these layers are separated by a wire mesh. Then charcoal filter, instead of sand, charcoal is used for filtering the water. So in this, there will be a gravel layer, then charcoal layer, then again a sand layer, then again a gravel layer. In this format, there is, you can, good evening, Arif. So there will be filtration through these charcoal filters, and there is PVC pipe filter, which is what we're talking about. So in PVC pipe filters, PVC pipes 1 to 1.2 meter in length and a diameter, which is depending on the area of the roof. So 6-inch diameter pipe for a 1,500 square feet roof, and 8-inch diameter pipe for roofs more than 1,500 square feet. So I think this point is a bit important because this is what has been asked in the question. So this also serves as a filtration system because you see water coming out of here. Large particles will not come out through this outlet, or it will not enter the pipeline. So PVC pipes can also be used, can be considered as a filter. That to 6-inch pipe and 8-inch pipe. 6 in the case of roof areas having 1,500 feet square feet area. But if it exceeds this, you might have to use an 8-inch diameter pipe. So our question was, an 8-inch diameter of PVC pipe filter should be used for what area, and it is equal more than 1,500 square feet. If it is equal to and less than 1,500 square feet, a 6-inch pipe is what is going to be used. So next question. Induced recharge comes under which of the following? Is it a form of surface recharge, subsurface recharge, indirect recharge, or direct recharge? So this is coming under methods of artificial groundwater recharge. If you remember in the last class, we had discussed about natural methods to recharge groundwater. Rainwater harvesting and all is artificial methods of recharge recharge of groundwater. So that is broadly classified into direct and indirect methods. Under direct method, there are methods that involve recharging using surface methods of surface methods on surface and methods in subsurface. So in surface, these are the options: flooding, basins of percolation tanks, stream augmentation, ditch and furrow system. And in subsurface, you have recharge wells, dug wells, etc. Indirect method, we studied about something called induced recharge. That is, you're inducing recharge when you forcefully pump out some water. A cone of depression is created, which will again lead into recharging of these wells. So that is coming under indirect recharge. So here, artificial recharge involving pumping from aquifer to hydraulically connected with surface water. So water from the surface can be can be used as a source of water, a source of recharge for the groundwater. This is how it happens. Heavy pumping is lowering the groundwater level. Cone of depression created. Water level induces the surface water to replenish the groundwater. So induced recharge is a method of indirect recharge. There is also not only from surface water but also from unlined canals. This process can be done. So if you, the diagrams are representative of it. So our question was, induced recharge is coming under which of the following? It is coming under indirect recharge. Subsurface and surface is coming under direct recharge. So the correct answer for this question would be option C. Okay, moving on. The depth of the recharge trend should be in the range of. So recharge trend would again be a method of artificial recharge of groundwater. So what is the condition or what is the dimension of a recharge trench? The required dimension of a recharge trench is the question. You can drop in your answers in the chat box, after which I'll be discussing. Okay. So these are various structures that are created for artificial recharge. Recharge pit, recharge trench, recharge well, or it is also called an injection well, a recharge shaft. There are ponds or reservoirs constructed for the purpose of artificial recharge, surface storage, and recharge through dug and defunct bore wells. So let's look into a few of them. So we are talking about recharge trench over here. Recharge trench, the dimensions have been asked. It is provided where upper impervious layer of soil is shallow. So this conditions where such structures are constructed is an important thing. A lot of questions come asking under which condition is the recharge pit provided or under which condition is the recharge trench provided. So this uh, the circumstance or the condition of the pervious impervious aquifer rock that is for which a particular kind of structure is provided is important. Trench is excavated, it is filled with pebbles, boulders, brickbats, and the length should be in such a way that it is 0.5 to 1 meter wide and 1 to 1.5 meter deep. Okay, so the trend should be the three important points over here would be upper impervious layer of the soil is shallow. So the soil, if the soil is of such a way that the soil is impervious, but the impervious layer is only shallow, then recharge trench is one of the structures that can be constructed for artificial recharge in such a place. Not only that, the width has to be 0.5 to 1 meter wide and the depth has to be 1 to 1.5 meter deep. So these are the three important points under recharge trench. The question here was what should be the depth? 1 to 1.5 meter deep will be the answer for this. So again, this is constructed in places where the impervious layer of the soil is shallow. Upper impervious layer of the soil is shallow. There might be impervious layers towards the deep end of the soil. That's not what we are talking about. If the soil is having some impervious layer on the top and say that layer is only shallow, then you can construct a recharge trench on such places. So you see, recharge trench is constructed, and then they are removed and they are filled with pebbles, boulders, etc. for water to flow through this and get collected over here and recharge the groundwater. Next question: to accommodate more water, diameter of pitch shafts should normally be more than what dimension? So now we talked about recharge trench. So we are talking about pitch and shafts. What should be the diameter of pitch and shafts is the question. So pitch and shaft is again another method of artificial recharge. So again, where impervious layer is encountered at a shallow depth, the pitch and shafts are suitable. So we learned that recharge trench is also recharge trench is constructed in places where the upper impervious layer is shallow. But here, if the impervious layer is encountered at a shallow depth, they're talking about when pit is dug and we approach an impervious layer which is at a shallow depth from the surface, then in such places, pitch and shafts can be constructed as an artificial recharge structure. Diameter should normally be more than 2 meter to accommodate more water. Again, it is advantageous in the fact that it only requires, it does not require large areas like percolation. A huge area is not required. A narrow tank is sufficient, and also the loss of water in the form of soil moisture evaporation is also less in the case of pitch and shaft. So in case of pitch and shaft, the three important points are when the impervious layer is encountered at a very shallow depth, then pitch and shaft can be constructed. Diameter has to be more than 2 meter to accommodate more water. It requires only less area, plus the losses due to evaporation and soil moisture will be less when you use a pitch and shaft as the structure for artificial recharge. So these are the four important points when it comes to the recharge structure, pitch and shaft for artificial recharge. So the answer would be 2 meter, option D. Accommodate more water, diameter has to be more than 2 meter. Moving on. Which is the first state in India to have made rooftop rainwater harvesting structure compulsory for all the houses across the country, across the state? I think this is a question that we discussed in the last or the previous class also. So I believe you should be knowing the answer. Okay, so it's Tamil Nadu, was implemented in 2003, and then hence on all the houses requires a rooftop rainwater harvesting system compulsory when a new house is being constructed. Which of the following is not a source of water for recharge? Talking about groundwater recharge, rooftop, rooftop water bodies, stormwater drains, or sewage drains, which is not an option for recharge. So the answer is pretty obvious here. It is a sewage drains. You don't use sewage water for recharging any kind of uh, source of water, whether it is groundwater or any other source. So the clarity of the slide is a bit less. So various sources of water for recharge is rooftops, the water that you get from rain, paved and unpaved areas, majorly stormwater drains. This paved and unpaved areas will have surface runoff, which is going to go into slopes or collection points of slope or stormwater drains, which can be used as a source of water for recharge. And there are water bodies like lakes, ponds, tanks that can help in storing and then recharging groundwater. Stormwater drains again. So sewage drain is not a source of water for recharge. Moving on. Which out of the following are components of the rooftop harvesting system? So we had looked into rooftop harvesting. We looked at the major components as well as multiple number of other components also that are used when designing a proper rooftop harvesting system. So these are the components: catchment area, transportation, first flush, storage system, delivery system, and a filtration system. So the correct answer would be option B, all of the above. Moving on, what is the first flush component of the rooftop rainwater harvesting system? Okay, so first flush we discussed when it rains in the beginning, the first rain it might be contaminated with stuff from the atmosphere. So in order to remove that, there is a system that helps in removing the flush of the water that is received in the first shower. So a device used to flush up the water received in first shower will be the correct answer, option A. Moving on, which of the following is not a filtration system used in rooftop rainwater harvesting? So we discussed about three kinds of filtration systems: sand gravel, charcoal, and the PVC pipe filter. So all these three are filtration systems. So the correct answer for this question would be none of the above. That is, which of the following is not a filtration system is the question asked. So be careful of what is being asked in the question. All of these three are filtration systems. So the correct answer would be option D, none of the above. If they're talking about none of the above options given is not a filtration system is what is being talked about here. Okay, what is artificial groundwater recharge? Go through the options well and then drop in your answers. Okay, so the options here is the groundwater recharge is augmented at the rate much lesser than those under natural conditions of percolation. So this means that when the recharge is increased or is added on at a rate which is lesser than the rate at which the groundwater is getting collected due to natural percolation. Second option, the groundwater is added or recharge is being done at a rate which is more than the rate at which naturally the groundwater is receiving its water. If the groundwater is getting increased at the natural at a rate which is equal to the rate at which it is naturally obtaining water, is what these three options mean. So artificial recharge is basically when you when you recharge the groundwater, addition of water is happening, or the recharging collection of or the replenishing of water is happening at a rate which is higher than the rate at which it will naturally occur. So as a result of infiltration and depercolation, if the rate at which the water reaching or increasing the water table is say like 1 mm per day or 1 mm per month, then it is a very slow rate. But instead, if we are able to increase, say, 10 mm in 1 year, then that in, it is because of this increased rate in which we are able to artificially provide water to the groundwater that it is called an artificial recharge. So under natural conditions, under normal conditions, the rate at which the water is getting replenished is very low. But instead, when we can do it at a higher rate than the natural condition, that condition, or that is what is called artificial recharge. So here the option B, the groundwater recharge is augmented at a rate much higher than those under natural conditions of percolation would be the correct answer. Now, what kind of a recharge structure is provided in places with shallow impervious layers? We had looked into two recharge structures, recharge trench and recharge pits and shafts. And what is the condition that is required for the structure to be constructed? Okay, so recharge trench when the upper impervious layers of soil are shallow, then the recharge trench is provided in such area. Recharge pit uh, is generally a pit into which water you can pour in water. Then recharge well or injection well when the aquifers are located at a very deep depth, then this injection well is provided. It is similar to a tube well. It This injection well is when you pump surface water into the aquifer. That is what is called a recharge well or injection well, and it is suitable to recharge single or multiple aquifers. So, if the aquifer is very deep, as well as single and multiple aquifers can be recharged using recharge well. Then recharge shaft, we had earlier looked in the pitch and shafts where the impervious layers are at shallow depth. While digging, if you encounter impervious layer at shallow depths, then pitch and shafts can be constructed for that. Also for poorly permeable strata, that is overlying water table aquifers, in such places also recharge shafts can be constructed. So here places with shallow impervious layers, particularly upper layer is very impervious, then recharge trench can be constructed in such areas. Now, what kind of recharge structure is suitable for aquifers that are located at greater depths and where the aquifer are of low permeability nature? So the correct answer is option D, injection well. I just now talked about it. When the for single or multiple aquifers, and if the aquifers are at greater depth, then the suitable method is a recharge well or an injection well. Question here is asked is that suitable for aquifers that are located at greater depth. Also, another condition is the aquifers are of low permeability nature. Then you can use a an injection well. What is the primary benefit of rainwater harvesting? So option C, conserving and recharging groundwater is the primary benefit of rainwater harvesting. Air pollution is not a reason. All these are not reasons for rainwater harvesting. What is the main advantage of using underground tanks for rainwater harvesting? main advantage of using underground tank is they prevent water evaporation because often it is deep under or covered. So this is also helping the penetration of sunlight is reduced, so evaporation is also less. So correct answer is option A. Next question, which of the following is not a use of rainwater harvested through a rainwater harvesting system? The question is which is not a use of rainwater harvesting. And please look at the options correctly and answer. Read the question properly. They're asking for not a use of rainwater harvesting. We had discussed about what are the for what and all rainwater can be used. The correct option is option D. You cannot generate electricity using rainwater harvesting. Now, what does a sand gravel filter and rainwater harvesting system do? Does it store water, remove turbidity, color, and microorganism, direct rainwater into storage reservoirs, prevent soil erosion? Correct answer is option B. It is removing turbidity, color, and microorganisms from water. Now, what is the primary source of water for recharge in rainwater harvesting? The answer is option D, rooftops. Stormwater drain, lakes, ponds are also sources of, stormwater drains are also sources of recharge, but primary sources rooftops. So, in which area is the ditch and furrow system more suitable for artificial groundwater recharge? I don't think you'll be knowing those answers, so I'll just move on directly to the explanation. So, like I said, there are different methods of artificial recharge techniques, direct and indirect. Indirect, you have surface method and subsurface method. In surface method, there are four methods called flooding, basins of percolation tanks, stream augmentation, and ditch and furrow system. So the question here is talking about ditch and furrow system. So ditch and furrow system is something like this. There will be one ditch, then a furrow will be constructed. This is so that the first of all the water flow can be restricted because of the system, and here closely spaced ditches and furrows carry water from sources like stream and canal, and then what happens is since the flow rate is reduced, uh, the water um, contact time or the water is remaining on these ditches and furrows to a larger extent which is making it possible for this water to seep into the soil or infiltrate into the soil and recharge groundwater. So this is basically the the intention behind a ditch and furrow system is to increase the contact time of water with these with the soil, so that instead of flowing off at a fast rate, it will be flowing at a slower rate. It will have opportunities to get collected and then flow when the level increases. Meanwhile, recharging can occur. So this is the ditch and furrow system. Question here is, in which areas is the ditch and furrow system most suitable for groundwater recharge? Areas with irregular topography is most suitable for ditches or furrow systems. The correct answer is option A. Now, what is the primary reason for using rain sources in rainwater harvesting? We had discussed about this method of rainwater harvesting. Apart from rooftop and surface, there's something called rain sources. What is the primary reason to use rain sources? Okay, the primary reason, you see, this is a rain saucer. These are upside down umbrellas that will act as funnels to collect the water, and then this is connected to a barrel, which is then used for storing water. So it is basically used for collecting water. Option A will be the correct answer, to collect rainwater as it is falling from the sky. Now, which method of artificial recharge is suitable for areas with relatively flat topography? Just now we saw that ditch and furrow system is suitable for areas with irregular topography. Question here is, for areas with flat topography, what method of uh, recharge technique is suitable? Okay. So flooding is more suitable for relatively flat topography. Flooding is nothing but uh, flat surface. Water is collected at the flat surface, after which again this is increasing the collection time of water instead of the water flowing off. So when the water gets collected, the water will infiltrate slowly and it will be recharging the groundwater. So it is good for areas that is having relatively flat topography, the method of flooding. Now, which type of artificial recharge structure is cost effective for areas with shallow impervious layers? I think this is a repeated question. Recharge trench. Okay, so now we'll move on to the second revision part of the session. Meanwhile, we can take a 2 to 3 minutes break. And now the time is 7:04. So we'll be back here by 7:07. Let's move on to the revision of the second week's lecture and the questions in it. So, first question, which geological study is providing the chronological order of rock formations and helping to predict the presence or absence of aquifers below a rock formation? Okay, so the correct answer is option C. Petrology is the study of rocks, their composition, structure, and conditions that form them. Mineralogy is the study of minerals and their composition. Stratigraphy is giving us an idea about the presence and absence of aquifers. Paleontology is the study of ancient rocks that is analyzed by the presence of fossils. The correct answer is option C, stratigraphy. These are the explanations for the remaining terms in this question, if at all not familiar with it. So, what is the term for actual amount of water that can be extracted from a unit volume of aquifer by pumping or under the action of gravity? Okay, so the correct answer is specific yield. So we know that specific yield is the amount of water that is going through a unit volume of aquifer per unit head. And specific retention is the amount of water that is retained that flows out of the aquifer. Now, specific retention is the amount of water that is retained in the unit volume of aquifer uh, after this water that is flowing out as a result of gravity. Hydraulic conductivity, coefficient of permeability, all of them are terms that depict the ease with which water will flow in the aquifer. Porosity is the total volume of voids to the total volume of the soil. So for this, the correct answer would be option B. Now a soil sample has a total volume of 200 meter cube. Volume of voids is 50 meter cube. What is the porosity? Please do this problem, putting your answers here. Correct answer is option C. Porosity is the volume of voids to the total volume of the aquifer of the soil. So it is 50 divided by 200.25. What will be the answer if, I mean, okay, I don't think there's anything to say that. Okay. Which of the following areas is characterized by extensive heterogeneous and anisotropic unconfined aquifers? What type of water is commonly found there? So, in your lecture series, there is a portion that covers the type of aquifers, the type of water in various areas in India. We had discussed it. It will be there in the problem solving session of week 2 as well as in the lecture notes and as well as the questions that are being discussed now. So, please be familiar with all those regions. So the correct answer is option D. Indo-Gangetic alluvium has got hard water. So all the description for Himalayan highlands, Deccan Trap Foundation, coastal alluviums are also present in the lecture series. So see to it that you go through all of it. Next, which geological formation is partly permeable? It can store water and yield water, but yielding is quite slow. Correct. The option is acutard. Aquifer is when it is got good capability to store as well as yield water. Acufuge is when it cannot neither store nor transmit water. Acuclude is when it can store water like clay, but it cannot transmit water. So these are the explanations for these terms, also discussed several times. So please go through this, the examples as well as what all these formations are. Which out of the following statement is true regarding a confined aquifer? Correct answer is option A. It is confined between two impermeable beds and the water pressure is greater than the atmospheric pressure. Which aquifer has the pressure of the water equal to the atmospheric pressure? You can put your answers in the chat box. Which aquifer has the water surface at atmospheric pressure? Okay, it is the unconfined aquifer. Unconfined aquifer has the water table at atmospheric pressure. Confined aquifer has a pressure of the water more than the atmospheric pressure. Now, rhyolite is an example of what kind of rock? Okay, so here igneous rocks. Examples are granite, gabbro, rhyolite, and basalt. Sedimentary sandstone, limestone, siltstone, and halite. And metamorphic marble, slate, pyrite, and gneiss. So the correct answer is option B. Sedimentary, it is sandstone, limestone, siltstone, and halite. And metamorphic, it is marble, slate, pyrite, and gneiss. So do learn the examples as well. Now, which of the following is not does not correctly match a sedimentary rock with metamorphic rock? One is sedimentary, one is metamorphic. Which combination is wrong? This sedimentary and metamorphic, sedimentary, sedimentary and metamorphic, sedimentary and metamorphic. So limestone is a sedimentary rock, gneiss is a metamorphic rock, so it is a correct pair. Shale is a sedimentary rock, slate is a metamorphic rock, so this is also a correct pair. Sandstone is sedimentary, marble metamorphic, so this is also a correct pair. Granite is an igneous rock, and schist is a metamorphic I don't know. Schist is also a metamorphic rock. So the option A is the correct answer because they have asked the wrong pair over here. Which of the following processes lead to the formation of igneous rocks? Yeah, it is a cooling and solidification of molten magma or lava that is resulting in the formation of igneous rocks. Which of the following is an example of igneous rocks again? Correct, it is granite. Then which process is leading to the formation of metamorphic rocks from igneous or sedimentary rocks? Yeah, correct answer is option D, metamorphism. Then what is the ability of an earth material to transmit water called as? Yes, it is permeability. Then what is the boundary between the saturated and the unsaturated zone called? So correct answer is the water table. Now, which type of rock is characterized by the incomplete induration and preserved primary porosity? Consolidated, semi-consolidated, unconsolidated, or igneous rocks? So these are the different types of classification based on consolidation. Unconsolidated, semi-consolidated, consolidated. Rocks that are loose and uncemented are unconsolidated. Rocks that have undergone partial consolidation is semi. And rocks that are tightly compacted and cemented together are consolidated rocks. Here the porosity and permeability is very high. Here they have moderate porosity and permeability, low porosity and permeability. So the semi-consolidated rock is where the process of induration is incomplete and primary porosity is preserved. Here, very highly cemented one, no, very low porosity and permeability. Unconsolidated, very high permeability and porosity. So the correct answer is option B, semi-consolidated. Now we'll move on to the third week's revision. Some questions for that covers the week 3 revision. I don't think I've covered a lot of it, which I'll try covering in the coming classes if time permits. So, what is the term for Vados water that escapes into the atmosphere through transpiration and evaporation called as? Correct answer, soil water. So Vadose water is nothing but the water that is present in the top layers of the soil. That is called the zone of aeration. Zone of aeration or unsaturated zone. This is again divided into three layers. One is the root zone, second one intermediate zone, then the capillary fringe, and below that you get the water table and zone of saturation. Now, which of the following is correct about the pressure head in the Vadose zone? Correct answer is option C. The pressure head in the zone of saturation is equal to atmospheric pressure, whereas the pressure head in the for water in the Vado zone will be less because that zone is not saturated with water. It is only partially saturated with water, so the pressure will be less than the atmospheric pressure. What type of soil water is stored in large pores and can get drained easily under its own weight? Correct answer is gravitational water. Now, which term is used to describe the zone below the water table where all the pore spaces are saturated with water? Yes, the correct answer is zone of saturation. Then, what is the term used for local water table which is positioned above the regional water table? There's nothing stranded, displaced, or depressed water table that we are studying about, although we are studying about perched water tables, which is usually occurring when an impermeable formation in the middle of the unconfined aquifer is present and water gets collected on top of it. So it's called a pursed water table. Now, how does the hydraulic head measured in the saturated zone? Yes, so it is using a piezometer. Tensiometer is used for checking the pressure of soil water. Now, which zone of the geological profile is situated above the water table and plays a crucial role in contaminant transport before reaching groundwater? Correct answer is option D. There's nothing called a capillary zone. You call it a capillary fringe, the layer in Vado zone. Vado zone is the layer through which initially water will go, and there's a lot of filtration process that will occur there. So it is also helping in a way for not removal but delaying the contaminant transport into groundwater. Which model is calculating the vulnerability index of groundwater by considering these parameters? The correct answer is drastic model. This has been discussed in the lecture series, so be sure to go through it. Which is used for predicting solute transportation in the Vado zone for groundwater vulnerability assessment. So it is Hydrus model. Hydrus is predicting solute transportation, which can be used for groundwater vulnerability assessment. If they're asking which model is used for groundwater vulnerability assessment, it is drastic. Which model is used for solute transportation, it is Hydrus. Which zone of water zone is characterized by pore spaces that are air filled above the capillary zone? Which zone comes above the capillary fringe? It is the intermediate zone. Sorry, this answer is wrong. It is the intermediate zone. C, option C. I'll be correcting it and providing. So that will be all for today's session. Thank you for attending and participating in the session today. We'll be meeting the following week with I believe the last week, week 12. I'll be possibly discussing some random revision questions as well. So if you have any doubts, you can feel free to ask or you're free to leave the session. Exam date has not been announced. Although the type of exam has come, you can check the announcement section in the Swayam portal. This will be an online exam and your centers will be reported to you soon.